Hello friends, myself Mrs. Vaishali Harak from MVP Samaj KBT College of Engineering Nasik. Today we are going to discuss resistant temperature coefficient, that is RTC. Now RTC, it is a factor by which the resistance of a material changes with respect to temperature. It is defined as the ratio of change in resistance per degree Celsius to resistance at T degree Celsius. We can explain this by using this graph. This is a graph of resistance versus temperature. Here resistance goes on increasing with respect to temperature. Now we are taking two different temperature, T1 degree Celsius and T2 degree Celsius. So corresponding resistance, R1 it is a resistance at T1 degree Celsius, R2 it is a resistance as T2 degree Celsius. Now RTC it is denoted by letter alpha. So RTC at T1 degree Celsius it is alpha 1 and resistance at T1 degree Celsius we know that it is R1. So RTC it is a ratio of change in resistance. So change in resistance, if we assume the temperature changes from T1 to T2 degree Celsius, so resistance get changes from R1 to R2. So change in resistance it is R2 minus R1 and corresponding change in temperature it is T2 minus T1. If we want to calculate the RTC at T1 degree Celsius, then it is denoted by alpha 1. So alpha 1 equals to change in resistance per degree Celsius, that is R2 minus R1 divided by T2 minus T1 to the resistance at T1 degree Celsius. So resistance at T1 degree Celsius it is denoted by R1. So we can denote it as alpha 1 equals to R2 minus R1 upon T2 minus T1 upon R1. Or it is also defined as R2 minus R1 upon T2 minus T1, it is the slope of the graph. So it is also defined as slope of graph divided by resistance. Now unit of RTC, as it is the ratio of change in resistance per degree Celsius, the unit of resistance it is ohm per degree Celsius, that is temperature it is in degree Celsius, divided by resistance, again unit is ohm. So unit of RTC it is per degree Celsius. Now we want to calculate the RTC at 0 degree Celsius. In this graph, suppose the temperature get changes. Suppose alpha 0, here temperature get changes from T0 to T1. So corresponding resistance changes from R0 to R1. So alpha 0 it is change in resistance, that is R1 minus R0 divided by T1 minus 0. That T0 it is 0 degree Celsius, so it is T1 minus 0 divided by, as we are calculate RTC at 0 degree Celsius, so corresponding resistance is R0. So alpha 0 equals to R1 minus R0 upon T1 R0. So by rearranging this, it is R1 minus R0 equal to R0 alpha 0 T1. So R1 equals to R0 plus R0 alpha 0 T1. So R1 equals to R0 1 plus alpha 0 T1. So this is a resistance at T1 degree Celsius. If we calculate the resistance at T degree Celsius, then we are denoted it is RT. So RT equals to R0 1 plus alpha 0 T. And also we have alpha 1 equals to R2 minus R1 divided by T2 minus T1 divided by R1, right? So alpha again we can rearrange. So R1 alpha 1 T2 minus T1 equals to R2 minus R1. So R2 equals to R1 plus R1 alpha 1 T2 minus T1. So R2 equals to, I can take R1 common. So R2 equals to R1 1 plus alpha 1 T2 minus T1. So we are getting the formula for R2. It is resistance at T2 degree Celsius R2 equals to R1 1 plus alpha 1 T2 minus T1. Here T2 minus T1 it is change in temperature, and alpha 1 it is RTC at T1 degree Celsius. Now next we have to see the effect of temperature on RTC. For that, let R1 it is the initial resistance at T1 degree Celsius, and R2 it is the final resistance at T2 degree Celsius. So we are getting R2 equals to R1 1 plus alpha 1 T2 minus T1. Now if same conductor it is cooled from T2 to T1 degree Celsius, means resistance get changes from R2 to R1, means here starting resistance is R2 and final resistance is R1. So in that case our equation is R1 equals to R2 1 plus alpha 2 T1 minus T2. So we have this two equation. Equation first is R2 and equation second is for R1. Now putting the value of R1 in equation 1. So we are getting R2 equals to R2 1 plus alpha 2 T1 minus T2 multiply by 1 plus alpha 1 T2 minus T1. So R2 get cancelled. So we are getting 1 equal to 1 plus alpha 2 T1 minus T2 1 plus alpha 1 T2 minus T1. So I can rearrange this equation like this. I can take 1 plus alpha 2 T1 minus T2 on left hand side. So it is on right hand side it is 1 upon 1 plus alpha 1 T2 minus T1. Now alpha 2 T1 minus T2 is equal to 1 upon 1 plus alpha 1 T2 minus T1, and this plus 1 it comes at minus 1. So we can cross multiply. So 1 minus 1 minus alpha 1 T2 minus T1 divided by 1 plus alpha 1 T2 minus T1. So alpha 2 T1 minus T2 we are getting plus 1 minus 1 is get cancelled. So it comes minus alpha 1 T2 minus T1 divided by 1 plus alpha 1 T2 minus T1. Now minus alpha 1 T2 minus T1 we can also write alpha 1 T1 minus T2. As we are interchange T2 minus T1 as T1 minus T2, so minus sign outside, so minus minus it becomes plus. So it comes plus alpha 1 T1 minus T2. So I can put that. So our equation is alpha 2 T1 minus T2 equal to alpha 1 T1 minus T2 divided by 1 plus alpha 1 T2 minus T1. So T1 minus T2 on both the side it get cancelled. So we are getting alpha 2 equals to alpha 1 upon 1 plus alpha 1 T2 minus T1, or it is alpha 1 upon alpha 2 it is equals to 1 plus alpha 1 T2 minus T1. So we are getting this alpha 2 equals to alpha 1 upon 1 plus alpha 1 T2 minus T1. So RTC it is inversely proportional to this T2 minus T1. Means it is a change in temperature, means RTC it is inversely proportional to temperature. So as the temperature increases this RTC goes on decreasing, or as the temperature decreases this RTC goes on increasing. So effect of temperature on RTC, that RTC it is inversely proportional to temperature. Now similarly here RTC at T degree Celsius we can calculate it alpha 0, that is RTC at 0 degree Celsius is given. So alpha T equals to alpha 0 upon 1 plus alpha 0, that change in temperature it is T minus T0. T0 it is 0 degree Celsius, so it is T minus 0. So we are getting alpha T equals to alpha 0 upon 1 plus alpha 0 T. Now rearrange this equation. So alpha T multiply by 1 plus alpha 0 T equals to alpha 0. So alpha T plus alpha T alpha 0 T equals to alpha 0. So alpha T equals to alpha 0 minus alpha 0 alpha T into T. So alpha T equals to alpha 0. I take alpha 0, it is common. So in bracket 1 minus alpha T into T. So finally we are getting alpha 0 equals to alpha T upon 1 minus alpha T into T. Now next is RTC of a composite conductor. Now here composite conductor means that conductor which is made up of two or more different material. In this figure, this is a composite conductor which is made up of two different material, material 1 and material 2. Now material 1 has resistance R1 and RTC is alpha 1, and material 2 has resistance R2 and RTC alpha 2. Now RTC of composite conductor we are denoted by alpha 1 2. So we can calculate it that RTC of composite conductor alpha 1 2 equal to R1 alpha 1 plus R2 alpha 2 upon R1 plus R2. As these two material they are connected in series, so equivalent resistance it is R1 plus R2. So we are getting RTC alpha 1 2 it is R1 alpha 1 plus R2 alpha 2 upon R1 plus R2. So this is about resistance temperature coefficient. Thank you.